Welcome back to Vijay Academy. So in this video, I am explaining exercise 1.2 as per new textbook. So the first question is prove that root 5 is irrational. So to prove root 5 is irrational, we use contradiction method. So in the contradiction method, we basically take the given number as rational and then we come to know that the given number cannot be written in the form of rational. So we write that the assumption is wrong and then we write root 5 is irrational. So let us assume that root 5 is rational. Assume root 5 is rational. So we know that every rational number can be written in the form of p by q, where p and q are co-primes and q is not equal to 0. So I'll repeat, any number that can be written in the form of p by q and where p and q are integers and also they are co-primes and q is not equal to 0. So now let us write root 5 equals to p by q. Now let us try to write root 5 in the form of rational number. So we need to remove the square root. To remove the square root, let us square it on both sides. Squaring on both sides, we get root 5 the whole square becomes 5, and in the RHS we get p square by q square, and transpose q square to LHS we get 5q square equals to p square. Now we got that p square equals to 5 times q square, which means p square is a multiple of 5. So 5 divides p square. 5 divides p square. Therefore 5 divides p also. We can write that therefore 5 divides p also. So this is from theorem 1.2. It says that any prime number divides p square, it divides p also. So let me take this as equation 1. Now in this equation means in this statement we came to know that 5 divides p, which means p is a multiple of 5. So let me take that p is a multiple of 5, that p equals to 5 times some number. So let me take that as k. So now again let me square it on both sides. Squaring on both sides we get p square equals to 25k square. Then let me replace p square by 5 times q square. So we get 5q square equals to 25k square. So here we replaced p square by 5 times q square. Now let me transpose 5 to RHS. So we get q square equals to 25 by 5 into k square. That will give you q square equals to 5 times k square. Now from this we got to know that q square is a multiple of 5 because q square equals to 5 times k square. So we can write that 5 divides q square, and according to theorem 1.2 we can write that 5 divides q also. 5 divides q. So let me take this as statement 2. So look at the statements 1 and 2. So according to the statements 1 and 2 we got to know that 5 divides both p and q, but in the assumption we have taken that p by q as a rational number. So according to the rational number definition of the rational number, p and q should be co-primes, but here we got to know that 5 divides both p and q. So this will contradict the statement, this will contradict the assumption. Therefore we can write that assumption is wrong and therefore root 5 is irrational. So now we can write that 5 divides both p and q, which contradicts the assumption, Therefore root 5 is irrational. Now move on to the question number 2. Prove that 3 plus 2 root 5 is irrational. So again we use the contradiction method. So assume 3 plus 2 root 5 is rational. So let us write a rational number in the form of p by q. So 3 plus 2 root 5 equals to P by Q, and transpose 3 to RHS, we get 2 times root 5 equals to P by Q minus 3, and take the LCM of Q and 1, we get Q as the common denominator, and we get the numerator P minus 3Q, so which is equals to 2 root 5, and transpose 2 also and isolate root 5, so we get root 5 on one side of the equal sign, and then in the RHS we get P minus 3Q divided by 2Q. So now from this, after when you transpose 2 to RHS, it goes to denominator, so we write that as 2Q. Now look at the equation that we get here. So in LHS we have an irrational number, but in the RHS we have a rational number. So this never happens. An irrational number cannot come equals to rational number. So this contradicts the assumption. So now we can write that root 5 is irrational. Root 5 is irrational, but P minus 3Q divided by 2Q is rational, which contradicts the assumption. Therefore we can write that 3 plus 2 root 5 is irrational. So whenever you get the question like a rational number, a combination of a rational number and an irrational number, please follow this method. So you just transpose all the rational values to the other side of the equal sign and isolate an irrational part to one side of the equal sign, and that will give you the assumption wrong, and therefore you can write the given statement is proved. So next question, prove that the following are irrationals. So in that the first one is 1 by root 2. So again we can assume 1 by root 2 is rational. So we can write 1 by root 2 equals to P by Q, and then we can just reciprocal this on both sides. We get root 2 equals to Q by P, and now we can say that root 2 is irrational, but P by Q is rational. Therefore we can write which contradicts the assumption. Therefore we can write that 1 by root 2 is irrational. So similarly we need to do in the case of second question also, that you first assume that 7 root 5 is rational, and then you can write that 7 root 5 equals to P by Q. Just isolate the irrational part by transposing a rational part to other side of the equal sign. So we can write root 5 equals to P divided by 7Q, and then you can write root 5 is irrational, and and P by 7Q as rational number, and write the same steps that we have followed in the previous question. And similarly for even question number 3 also, we just first write the first step that 6 plus root 2 is rational, and the second step you can write 6 plus root 2 equals to P by Q, and transpose 6 to RHS to isolate root 2, and we get root 2 equals to P divided by Q minus 6, and take the LCM of Q and 1, so we get the common denominator Q, and we get the numerator P minus 6Q, that is equal to root 2. So here again follow the same rules, that write root 2 is irrational, but P minus 6Q by Q is rational, and therefore you can write which contradicts the assumption. Therefore 6 plus root 2 is an irrational number. So thank you children, please subscribe to my channel and click on the bell icon for the new videos, that in the next video I'll be teaching the polynomials. Please subscribe to my channel and also click on the bell icon for the new videos. Thank you so much.